Alright, so again, we're switching gears now. Let's talk about some triangle stuff. Every triangle, well, first of all, how many sides are on a triangle? Three. How many angles are in a triangle?
Two. I mean, one.
Three. So 3 sides, 3 angles. Now, every triangle has at least 2 acute angles. That's the only way a triangle can be built. 2 of the angles are going to be cute little small ones, less than 90 degrees. Now, the third angle, though, is how we can classify or name a triangle, because that third angle could be an obtuse one, it could be a small little acute one, it could be exactly 90 degrees. So we use the third angle to give it an angle name. And another way that we classify or name triangles is by their sides. Hopefully you're remembering this from last year. I taught my kids last year you need to have a first and a last name for your triangle. It needs to have its angle name and its side name. Okay, you give it 2 names. Sides with the same measure are congruent segments. Remember that word, same, congruent. Okay, and so then we will also give it special side names, and we'll remind ourselves of those in just a moment. If you look at this first little section, we're going to classify or name the triangles based on their angles. So first we're going to remind ourselves of the angle names. This first triangle, if you notice, each little angle is a little small cute one. It's less than that perfect 90 degrees. So this has 3 acute angles in it. Because that third angle is also acute, we would call it an acute triangle. So when all 3 of our angles in a triangle are acute small ones, we call it an acute triangle. What does this little box on the second one indicate? Right angle or 90 degrees. So that means these other ones are our 2 acute ones, but we have 1 right angle in there. Because this third angle is a right angle, we would call it a right triangle. Now in this last example, you'll notice 1, 2 of our little small acute ones, and then I see this big wide angle. This one's wider than 90 degrees. It has 1 obtuse angle in it. So because that third angle is obtuse, we call this an obtuse triangle. Last year I had my kids think of obtuse, think of obese, big, open, wide, okay? Just to help you think of the letters and the vocab. All right, let's talk about our side names. Connor, erase please, and I'll move the paper.
Go.
You know you want to be in the spotlight. You know you want everybody to see you.
No.
What's that?
Oh, that's true. I don't know what it is. It's something with a microphone. Hey, you take too long. Oh, well, then I'm just quick. I don't know what to tell you. Okay, so now let's talk about our side names here. If we look at this first triangle, there are no markings on it. Notice that the other ones have markings. Hopefully you're remembering that these markings tell you they're same measure. So if I have one here with no congruent or same sides, does anybody remember what that's called? I'll give you a hint. It starts with an S. Scalene. Very good. So no congruent sides is a scalene triangle. Last year I told my kids to remember it by you never weigh the same. If I were to wake up this morning and stand on the scale, it's going to say something less than what it would after school. Because I haven't eaten anything yet, right? I'm not as heavy. Okay, and chances are I'm on my way to the shower, right? Wearing less clothes. You don't have shoes on. I wouldn't be wearing my boots yet. Okay, when I get home, that's different. So your scale's never the same. If you're gaining weight, it goes up. If you're losing weight, it goes down. Your scale's never the same every time you step on it. Okay, so that's how you can think about scaling. No sides the same, scale's never the same. What if we have two congruent sides? That's what these markings mean. We have two congruent sides. Oh, isosceles, good. And the way I taught my kids that was you have two eyes. Eyes and isosceles. Okay, isosceles. That's I-S-O-S-C-E-L-E-S. Okay, an isosceles triangle has two congruent sides. Two eyes, isosceles, two congruent sides. This last one, we have three congruent sides. Does anybody remember what that one's called?
Equilateral.
Equilateral, very good. All the same, so they're all equal. It has the word equal in it. Equilateral. Okay, so that would be an equilateral triangle. Now, we've talked about the names individually, but again, we really give it a first and a last name. So we put an angle name with a side name to officially name a triangle. So let's look at this example here. We have a triangular pennant that's tied to a pole, and so we're looking at the pennant here. Okay, I see that this is marked as 20 degrees, and these look like little acute angles too. So it has three acute angles in it. And how many sides are the same length?
Two.
Yes, that's what these markings mean. So these two are the same. And two two sides. Two sides that are the same length. Okay, so what's the angle name? If we have three acute angles? Acute. So it's an acute. And then if we have two sides that are the same, what word do we use for that? Isosceles. So it's an acute isosceles triangle there. Our little pennant flag is an acute isosceles triangle. Okay, let's look at two more examples down here and see if we can name those triangles based on a verbal description, not a picture. See, number one here says that we have a triangle with three acute angles and three congruent sides. Kelsey, what did you think that would be? What names would I give it? First and last. Three acute angles and three congruent sides.
Equilateral.
Acute equilateral, very good. An acute equilateral triangle, very good. So when all three angles are small and cute, it's acute. When all sides are the same, it's equilateral. Number two says a triangle with one right angle and no congruent sides. Brianna, what would that be?
A right triangle and scalene triangle.
Right scalene, good. So right because of the angle and scalene because none of the sides are the same. So a right scalene triangle. Very good. Okay, how do we feel about naming them? Was that a good reminder? We remember that stuff from last year now? Okay, let's talk about our angle relationships in triangles.